This is Team Fillmore, and this is our presentation on our software testing project. First, we had to write a program that would implement a class roll system with the following specifications for student data. It needed a name, a USF ID, an email, a grade for the presentation, a grade for essay number 1, a grade for essay number 2, and a grade for the term project. The program also needed to have these features. It needed to be able to read and write student data, add and delete students, retrieve student data based on search by name, ID, or email, and update any or all data fields. Now here's where things start to get interesting. Because this was a software testing class, we also had to seed faults into our program and then have another team try and debug the software. The types of faults we seeded range from things like null pointer references to syntax errors like using the assignment operator instead of the equals to operator. So now on to testing. Our team received only the source code. We didn't receive any documentation, however, so we had no idea how the program handled the file input and output. We performed 3 types of testing: closed box testing, open box testing, and stress testing. Closed box testing is just using the software and seeing if it does what it's supposed to do, and it helps to get an idea of where the bugs are. We first compiled and just played around a bit, getting errors like the one shown here, which was an infinite loop in the program. This was like whenever we tried to input anything other than an integer, and there was just no way to exit the loop. It just kept going on forever. Trying some of the different menu options, we were also met with some program crashes like in the figure below. Here, we first tried to access the delete a student menu, as can be seen, and then we tried to access the display all students menu. And here we get a vector subscript out of range error. Now this is good to keep in mind for later when we go to look and see if there's a function to display all students and to see if we can figure out where these vector subscript errors are coming from. Now that we've done some closed box testing and really gotten a feel for the program and where some possible locations of errors are, we went on to open box testing. And this is where we can look at the source code and try and isolate the causes of the errors that we discovered while we were performing our closed box tests. For a lot of this, we use Visual Studio because it allows you to collapse the code and it makes things easier to read and see, and you can expand different functions and classes, and really helps tidy things up. In the previous slides on closed box testing, we encountered a vector subscript out of bounds error while trying to display all students. Now, we chose to expand the class here that's known as student recs instead of just the record class, because the record class, as part of the documentation, said that it just contained all the data for each student, like their name and ID and everything like that. So we expanded this class, and as we can see here in this figure, on line 432, there's a function that says print all students. So great, this is most likely where the error was at. So we expanded this function, and inside of this function is a for loop. And here is the for loop, which is for int I equals 0, I less than or equal to student records.size, increment I. This is the cause of the out of bounds error, because here we're trying to access the nth element of an array, but since array start at 0, you can only access the nth minus 1 element, as this becomes the last one. So something like this is easy to fix. All you have to do is just make it, instead of I is less than or equal to the size, you just make it I is less than the size. So when you get to your last increment, you're at the last element and not the element past that, which is your out of bounds error. Now, after doing some closed box testing and some open box testing, we basically just kept doing a combination of closed box and open box testing. During our original run of closed box testing, we weren't able to make it all the way through the menu systems and things like that without encountering crashes, so we couldn't exactly determine if the whole program worked correctly or not anyway. So we had to go into the open box testing and find some bugs, fix them if we could, and then we went back to the closed box testing and then got deeper into the menu systems and everything, and then encountered new bugs. Then we went back to the source code, and we just basically rinsed, repeated, found some errors in like the file in and out and things like that. However, there was one notable exception, and that is that one of the test environments we used was Linux. And we couldn't even compile because we had to include the header file limits, so numeric limits is properly defined, and we can see this in our little console output here. This was using the G++ compiler. And for some reason on Windows, this seems to be included in the standard library header, but I can't figure out why, but it's not included in the library files in Linux, so you just have to include this, and then you can have cross-platform compatibility. Now going back over to our Windows environment, we use the Visual Studio debugger by using breakpoints to find some bugs. We were having issues with some of the functions, and we were getting out of bounds errors, and we couldn't really figure out why, so we put in some breakpoints, and what these allow you to do is stop the program from executing when it encounters a breakpoint, and then you can go in and check what all the values are in memory and things like that. And this is how we were able to figure out that these functions were returning these really strange values. As we can see here, I, at this point in the execution, was like -8 billion something, and that's obviously like completely not right. And this is probably just because after not being able to search through all the student records and find what it was looking for, there was no way to handle returning not finding a student, so I was just incremented, and it was just in that memory location, just whatever leftover value was there is probably what it just passed back. And this was giving us crashes, and using the breakpoints in the Visual Studio debugger, it helped a lot to find this error. Finally, we wanted to perform some stress testing on the program just to see how it would handle large amounts of data. So, I mean, it's not like it was going to really ever experience this. This was mostly done out of curiosity. But what we did was we took the input text file and put about 100,000 students into it, just by copying and pasting. Throw a little format over here. And we even found that by putting the spaces in between, it even made their tabular output to be incorrect, which caused some, cosmetic faults with the display and things like that as well. And just for some context for the next slides, what's shown here is the main function. As we can see, as soon as we load the program, it just loads the data. So just keep that in mind. Now, once again, we're using the Visual Studio debugger. It has diagnostic tools that were pretty handy for this type of test. We can see that it has diagnostic session, time, memory, snapshot, CPU usage. So this snapshot was taken at 18 seconds, and we can tell by the memory graph that program data is being loaded, but as you can see here, there's just a blank screen. But that's why we wanted to explain before that program data is loaded immediately. So, as we can see, our menu finally loaded. This was somewhere around the 30-second mark. And the only issue is that the program doesn't inform the user that it's loading data, so the user might think that their program's broken, but like we said before, this is probably an unlikely scenario, and we can mostly call this a cosmetic bug, since it doesn't actually cause the program to crash or anything like that. And also, if you're wondering why there's these spikes in the memory graph, that's because of the use of vectors instead of normal arrays. And what a vector does is every time it reaches its maximum capacity, it'll double itself in size, copy the old array into the new array, and then delete the old array. And that's what makes them so powerful, is that they can dynamically change their size, and amongst other things. And that concludes our testing and leads us into our conclusions. So, using all the methods that we've described, we were able to uncover an astounding 52 faults in the program. Most of these faults just dealt with input verification or improper use of switch statements or out-of-bounds errors. Some were merely cosmetic, like sections of unused code being commented out, but still left in the final code. There was also some dead code, like some functions that were never called, and even though they were fully defined and everything, and they were just using up space in the source code, which makes the code harder to read and things like that. One of particular interest was improper use of a library function known as s2i, which turns a string into an integer. According to documentation, this function will throw an exception if a non-integer value is encountered after whitespace characters. This type of function should be in a try block that can catch and handle the exception thrown by s2i, otherwise it'll just cause a crash. And I discovered this when trying to input letters instead of numbers in the input file, like as if somebody was just going to manually input it. And this is probably unlikely to happen as well, but it was an interesting bug nonetheless. Some of the other faults were just improper use of object-oriented design. For example, like all the menu functions were inside of another class instead of being their own class. So this made testing the menu functions by themselves very difficult. Like I said, we had to do some closed box testing, then open box testing, and it was hard to kind of get through the entire code without encountering errors and things like that. And it was hard to test things by themselves. And like all good software testers, we reported all of these faults in a fault report with suggested fixes, and these are to be sent back to the engineers. And that concludes our software testing term project. Thanks.